Hello everyone, and now on to ZigZag task 5. So, modify the skeleton program to allow a simulation to end. So at the moment we only end when the user selects 9 in the main menu. We want to introduce new functionality to automatically end the simulation. So the two conditions, all the ends die or all the food within the simulation runs out. Give a reason, one of those two reasons, to the user, and here we go. Up, copy, paste it, rename it to, I suppose, Z5, and we're here. Cool, don't need the original. So we are here. This is currently how it kind of only exists on 9. What we want, this is where it gets interesting. No, not this. We want to modify advanced stage in the simulation class to see if the simulation should end and set. What's interesting is that they want new attributes that are literally just going to be here to be passed from the simulation to the main method. So has simulation ended, there's the getters. So we want a simulation ended attribute and an end reason attribute with some getters, and then they will pass this to the main method will check them to see whether it's ended. So we are in the simulation class, which is here, constructor. Yeah, so in the constructor, let's have self dot underscore ended. So we start with the simulation not ended, and self dot underscore end reason reason that's none to start with. We writing some getters for this, so I'll put them along with this is a public getter. So let's put it here. Def get, what do you want to call it? Simulation ended. Or has simulation ended? Yeah, it's a sort of get for a boolean because it's a yes or no question. Has simulation ended? Take self, and you just return self dot ended. Cool. And def get end reason self return self dot underscore end reason. Remember, there's always marks to be gotten. If they want you to set up some new attributes, some getter setters, initialize them in the constructor. That's important. You don't want an error trying to access them when they don't exist. And then we've got that's the groundwork. This is where we're going to store the data. And then the magic or the logic will happen in advanced stage. And this is for each of the advanced of stage. We do all of this thing. What we want to be doing is, I guess, at the very end. Yeah, at the very end, but still in the loop. So I'm like, yeah, that here sounds good. We are going to say, so what are that's the end. So if length of the ends list, no, self underscore ends, yeah, that's where we have the ends list. So if that ever becomes equal to 0, we want to, hello. Oh, that's because syntax is broken. Right, so if this is ever equal to 0, we want to set ended true, and we want to set and reason to no more live ends. And then we want to break out of the update loop because there's no point, the simulation has ended, there's no point updating. That's for the ends. And then there's another one if we run out of food. So run out of food is a little bit fiddlier because the food in the simulation is in 2 places. They're not clear because we have food in the nest, which is in the nest, we have a getter for food level, but we also have foods on the cells. Now, unlike the arms, the simulation doesn't hold a list of all the available food, so we're going to need to go over the grid and for each cell call the amount of food to see whether it's 0 or not. All the food within the simulation runs out means that I should include the nest one, just kind of for clarity. So let's say remaining food, or like food left. That's probably a shorter one. Food left starts with 0, and then for n in self nest, right? Food left increment with n dot get class nest. This is kind of referring, knowing the functions and the method is helpful because it saves you time on the die. So it's get food level. get food level, don't forget the brackets. That's the nest. And then for all the cells, for C in self dot underscore grid is where the cells are. We're also going to do food left, increment this with C dot, and it's get food available. It's not the same name as the nest, I'm pretty sure. Get amount of food as opposed to level, whatever. One is countable, the other isn't, I suppose. Get amount of food. Now we're here, we've summed up all of the food left in the simulation, and if food left is null, then we are going to, same deal, do the same thing as here, except slightly different. No more food. And break. So we've done the changes to the simulation class, but we still, so far, we're not really exiting. We're detecting, with the simulation knows that it has ended, but main does not know that yet. So before we display the menu, what I want to do is we say if this simulation dot has ended, then in that case we print simulation ended, and then after that we're just going to go this simulation dot get end reason bracket bracket. Okay, all right, let's see if that does the job. So for the testing, they're saying, well, just kind of advance the simulation, yeah, until you get some kind of message saying it's finished. So let's do that. Didn't do anything because we still, still loads of food because I've not put the, we don't have the previous changes of like ants dying of old age or food perishing. So this is going to take a little bit longer than if we had them. Another 15 of them. They're still okay. So they've cleared that source of food. They seem to be starting on that one. So let's go to another 15. Okay. Simulation ended. No more live ends. Okay, I don't know what's happened. It'd be nice if it displayed, well, what details is it going to display? It's going to display a nest, and then maybe still some food left. But still, that has worked. I wish I could test the other, but again, those tasks, I mean, the tasks are hard to test the way they specify, but then the specification of the testing, right? You could have something that the AQA would have. The reason they've got 4 or 5 simulation, one has got a 2 nest, so there's probably something going on over there, is to test, to be able to set the certain circumstances that make the testing of some tasks easier. Anyway, that was it for ZigZag task 5. We're done in 7 minutes, which is nice. And I will see you very soon for, I suppose, task 6, as per integer arithmetic logic.